Okay, good afternoon, everybody. We are live. 8 seconds, 13 seconds, uh, 19 seconds. All right. Yeah, I have typed again the solution for the exercise 2.2 because if you remember in the previous video we got an error over here and it was left as an exercise to the reader, for the reader, to the reader, and probably you guys already knew. I will take 1 minute to expand this function. In production, it looks good to have this syntax, but when you are learning a language, in this case Scala, or a paradigm, in this case the functional programming approach to solve problems, it is good to understand what's happening at some level, not at the compiler level. I mean, you have to have a limit until you are going to stop digging. So, and for us, it is to see how this syntax looks with explicit variables. In the previous video, we said something like this. Okay, because I was confused in the problem statement because of this, but there is no need for confusion because the problem says that the first argument, like this one, is greater than the second argument. Probably the confusion for some people will arise from the fact that you are comparing this argument, and they will say, someone will say, and this is the second parameter, so this is big, but the function, it is A. The first parameter is greater than B. And now we have true for both functions. I'm going to get rid of this code. Now exercise 2.3, which is about a concept called currying or curry. It is the name of this problem, curry 2.3, in honoring the work of logician Haskell Curry. So they ask, and they provide, the authors provide the type signature for the function related to this problem, which is great. There are 3 type variables, and the problem says that you will receive a function f of 2 arguments returning a C type, and the result type for this function, it will be another function that will request or expect 1 argument at a time. So let us take a look at the book. Sorry, 5 minutes. I don't know if someone will get pissed off. For me, disclosing this is you know, it's not my intention to show this to please anyone. You know, buy the book if you can afford it. You know. Okay, the expected type is a function which will expect the resulting type that will expect the arguments one by one. I don't know how to fight this nervous in me. I mean, there's no one watching this video, see audience, and it still feels like the chance of failing. You know, what if I fail? Some kind of like that. But remember what Steve Jobs said in a video. You need to be willing to crash and burn. Okay, so let's crash and burn, and let's do it fast so we can recover and learn in the process. Okay, you can type the solution in this line. You're going to see. Okay. You are given a function f with two arguments of type a and b specified over here, and you are returning, they are returning a c type, a value of c type. You have to return a function which expects an a, and it will give you another function. This function will give you another one which in turn expects a d, and you know, at the end it will return c. How do you go about implementing this function? For the first, for starters, you are returning a function. Okay. Let's try with this. This function that you are returning expects an a. So you write an a. Okay. You can write something like this of type a, but Scala will infer the Scala system will infer the type in most of the cases. The return type for this function is another function. This function in turn expects a b. So you just type the letter b that the function is, you know, expecting. And in here, again, this is live. I didn't write this function before the video. I did it like more than a year ago, 1 year and a half, more than that. You might be asking, why are these parentheses? Because they want to make explicit that this is another function, and probably the association for this operator is like this, you know, to the left. And in here, you are saying, where are these parentheses going? You don't need those parentheses over here. Okay, you are the last function that you are returning will give you a c, sorry. And the only way to produce a c, because this value won't arise from anywhere. The user will give you this and this one. So now you have to produce this one. And why the user will give you these two? Because you are querying this function. You know, you have AB the user already have A and B. So the user have these two values. You can ask the user, give me A, here's another function. This function expects a B. Give me that B, you have it. Don't deny it. And the user will give you the B, the value of the type B. And then you have to produce a C. A way to produce, the only way you have to produce this value is to apply this function F over the values that they already give you. And this is how you can now move this over here. And this is our function curry, Haskell curry. Let's run this to see if something happens. How do you go about testing this function? You can have a valve, mult, which is a lambda expression. You are multiplying these two values. Okay. Let's try this. You have this mult A 7 B 5, and it will give you the multiplication, the product of A and B. Let's see if that's the case. Okay, great. This query is doing the transformation to a function of that expects one argument at a time. So let's get rid of this. And now we are declaring another value, query, and we call query, you see, and we provide mult. We want for the query function, this one, to to transform the multiplication function, which receives two parameters at the same time. Now, query will give you a function that expects one argument at a time. Query. What do you think it will happen over here? What do you think will happen here? If this was the REPL from Scala, you can use this. It will receive a name res0, and you can pass the other arguments. We will do that in a minute. Okay. Expect another. Hopefully you are seeing what's happening. Query now holds the function A to B and the transformation of the two of them. And in here we have stored the result for this operation. And for expect another, we already apply it to one argument. So we will call expect another with the other argument. Here's the final value. Let's try this. Okay. So to read, which holds this transformation, expects a value of type A. Look at this. And you get 1, 7. Then it gives you a function. You saw that function when we have the long string depicting some region in the memory. Sorry. Okay, and then you give the value, the second value B. Here it is. It gives you the final result, which is the application F of the function F over A and B. You give 7 and then 5, and it applies. You are giving one argument at a time. And here's more explicit. You know, expect another is a function that has already applied 7. Okay, that finishes the function curry. I don't know if it's difficult or if I don't explain myself in the way I thought. I will be doing it. Okay, I remember 10 years ago this function was kind of seemed very hard, but don't give up. You know, come back again. You will get there. Now, which leads me to the questions for the audience. These videos are for everybody, but now I will be thinking of the people that are struggling with these problems and that need a hint, which maybe it won't work because I shall start giving the hints instead of the solution. Maybe more thinking is necessary. And also, if you are curious, you have curiosity on which all this stuff come from. Curry, Haskell Curry, and the book has a note in here about someone called Finkel. You can go deep in the, and get more information. So I went to Wikipedia and looked for the name of this guy. This document was linked in Wikipedia, here it is. And it is in German. I don't know how to speak German, but it seems like the trick is taking place on these pages. So I went ahead and translate this paragraph. You can't select this paragraph. So I type this paragraph in Google Translate. Functions of several arguments can be divided into those of one argument based on our extended definition in the following way. So here it is. Now we have this amazing program, that help us to translate information. In the past, that wasn't the case. And I read somewhere that this guy, Israel Helfman, was translating in his desire to learn mathematics. He was translating book from the German language, word by word. You don't have to go with that these days. You have these tools. So they didn't show. They really love. They really went to big struggles. You in the present love the same way the science as they did in the past. But we take advantage of these machines, How did I get to know this guy? From his series, mathematics, algebra. I'm really enjoying geometry. Today I will retake in geometry after 4 days. Another place in which this Schofinkle and Haskell Curry are named is in this book by Alonso George that I haven't read. This is from the web archive. It's free, Not a great opportunity for all of us. Look at this. Okay. We have a winner. So Pinto. But again, Haskell Curry was a great logician. There is a programming language called Haskell, and just enjoy the information. And here's the thing about taking arguments one at a time. "23 minutes. I think we can call it a day. What is the show? This. I don't know if I made myself clear in the process of solving this problem. If I need to go again about it, you have 3 t-type variables. You have a function f taking a and b at the same time, producing a value of type c, and you are expected to return a function which takes one argument at a time. That's the concept they want to explain over here. Partial application of a function. If you read the book, maybe you can come up with another definition which uses the function partial one that they have designed and exemplified in the book on previous page before the exercise. Maybe you can use that over here. It's up to you. I mean, other than that, I think you will arrive at this definition. You ask the user to give you a, and you are given another function. Give me b. You give an entire function. Give me a. The user gives you a. Here it is. A. Now you have given me A, I give you a function that will ask you for a B. Give me B. The user gives you B. Here it is. Here it is. So I apply F to produce a C, which you can see here. That's all. Have fun as always. Have a great afternoon on this Tuesday. Bye.